Okay, it's time to take a look now at multiplying and dividing surds. We've looked at adding and subtracting in the last section, and when you're adding and subtracting, remember that square root of 3 plus the square root of 2 does not simplify because they're not like surds. With multiplication, however, square root of 3 times the square root of 2 doesn't matter about like surds. We can use the multiplication principle of surds, and that is that the square root of x times the square root of y is equal to the square root of xy. So that's just a little intro. Let's take a note or two about that. So we to divide and multiply surds. So square root of multiplication square root of x times the square root of y is just equal to the square root of xy. Now we've been going in this direction here in order to simplify surds, haven't we? Writing a surd as the factor as the product of two factors where one of those factors is a square number. Now, so we've been using this principle already, and we've been using the division principle as well to simplify surds, and that is the square root of x divided by the square root of y is equal to the square root of xy, or just the square root of x divided by y, depending on what these numbers are and how it works out. If it goes in evenly, then this is fine, isn't it? So if you have a look at some examples, that one I just looked at, or square root of 7 times the square root of 2 is the square root of 14. They're going to get a little bit more complicated than that, but in essence that's what it's about. And an example here for division is the square root of 8 divided by the square root of 2 is the square root of 4, which is just 2. Or you could write it as the square root of 7 divided by the square root of 3, which doesn't go in. You wouldn't write that as 7 divided by 3, you'd write it as the square root of 7 over 3. And that would just be how you'd leave it, because 7 and 3 don't come down anymore. So that's what we're working from. So let's just have a look at a few examples, a few further examples on how to apply the multiplication and division principle to surds. So I'll just have a look at a few examples. It's 2 root 3 times 3 root 15. 2 root 3 times 3 root 15. So we multiply the numbers together, 2 times 3 to get 6, and then we multiply the surd bits together to get 3 by 15, 45. Do you see what's happened there in two parts? Very similar to when we did 2x times 3y in algebra. We went 2 by 3, 6, x by y, xy. So it's very similar. There's a lot of parallels we can draw between surds and algebra. So 2 times 3 gives us a 6. The 3 by the 15 as a surd gives us 6 root 45. We can't leave it like that. We now need to simplify this 45. We know that 9 goes into 45, so we can write it like so. So that's 6 times the square root of 9 is 3, times the square root of 5 is the square root of 5. So we get 18 square root 5 as our solution there. Okay, next example, let's have a look at minus the square root of 10 divided by square root of 2. So what we can do here is divide 10 by 2 to get 5. But remember, a negative divided by a positive is a negative, so it would be minus the square root of 5. No problem there. Next example, 12 root 18 over 3 root 3. So in this example, what we'll do is we'll take the 12 and divide it by 3, so that'll give us 4. We'll take the 18 and divide by 3 to get square root 6. So 12 divided by 3, 4, 18 divided by 3, 6, 4 root 6. And that's in simplest form. Okay, we're going to have a look at an example like so. 3 square root of 3 by 3 root 5 minus the square root of 6. So what example number are we up to here? This was 1, 2, so this is example 4, 3, example 4. Okay, so this is, again, draw a parallel with algebra. if we had 2 outside of 3x plus 4, it's this distributive law where you take what's out the front and multiply by each term inside. So you get 2 times 3x would give you 6x, then you take the 2 and multiply by 4 to give you 8. So we're going to do the same thing here. We're going to take root 3 and times by 3 root 5. So the 3 doesn't have a number to multiply by, but the root 3 and the root 5 give you square root 15. And then you go root 3 times root 6, but it's minus, so that's minus the square root of 18. 3 sixes are 18. 15 can't be simplified, but I think this 18 can. Square root of 18. 18 has a square factor of 9. So let's split the 18 up into 9 by 2. So we get 3 square root 15 minus 3 square root 2. And that will be the simplest we can do. Now this next example would be great if you could pause once I've written out the question and then have a go at it yourselves. So it's 3 root 6 and then open up 2 root 10 minus 4 root 6. Okay, so have a go at this using that distributive law. Distributive meaning this distributes multiplication wise through both those terms, and then play through and see if we get the same answer. Okay, so I'm going to multiply these two together. 3 root 6 by 2 root 10 is 6 root 60. And then it's 3 root 6 times minus 4, so 3 times minus 4 is minus 12. Root 6 times root 6 is just root 36, or 6. So 6 root 60, let's make a better fist of that. That's 4 and 15, probably no better than that. So 6 by 4 by 15 minus 72. So that's 12. 6 by root 4 is 6 by 2 is 12. Root 15 minus 72 is our simplest solution there. Okay, so exercise 3C from the work requirements, that will be our work for class time on Tuesday. So please make sure that you are ready to go when we meet on Tuesday. See you then.